my name is Sean Kerr from the AMD Cloud Business Group. We thank you for joining this session today on how you can leverage AMD-based virtual machines in Azure to help facilitate workforce productivity and optimize user experiences, all for an affordable price point. I'll be speaking for about 10 minutes today on a couple of topics, including AMD's view of remote work trends, and then I'll talk about VM recommendations to help you achieve the best balance of user experience and cost for a variety of personas. Let's look at three external factors which are impacting the way IT managers are evaluating their IT infrastructure. The first is a trend to remote access. The pandemic forced a major shift from working in the office to working from home. This meant that enterprises had to quickly scale their VDI infrastructure to support an increased number of remote workers. Many look to the public cloud to help facilitate their resource requirements. Now, more and more businesses have adopted a remote-first culture as we come out of the pandemic. Secondly, many modern applications and websites today are greatly improving the way workers collaborate and stay productive. There are more ways than ever to create and consume information and data, as well as communicate with teammates. These modern applications and operating systems like Windows 11 all require greater resources to achieve their optimal performance and deliver a seamless user experience. This is more important than ever to choose the right cloud infrastructure to enable customers and workers to achieve more from their remote environment. And finally, all of these elements and factors stress the IT budget. Understanding where efficiencies can be found to deliver an optimal IT environment is paramount to the success of an organization. We can summarize what we're seeing as an increased demand for modern tools for today's remote workers. Applications that were once power user only tools are becoming more accessible to a larger audience. We're going to break down these audience types into personas or types of workers, and we're going to talk about infrastructure requirements needed to service these users. We've extensively tested and analyzed 3 AMD-powered Azure Virtual Machine offerings relevant to Azure Virtual Desktop. These are the VM families referenced in our recommendations sections. The EAV4 and DAV4 VMs are CPU-only general-purpose VMs, while the NVV4 VMs come with a partitionable GPU allocation. I'm not going to go into detail about these offerings, but you can find more about the VMs themselves by going to the Azure Docs page or the AMD partner page at amd.com/Azure. To help plot a course to some reasonable recommendations as a starting point, let's first group our remote corporate users into 4 types, or personas. In reality, this is a continuum with some blurring between personas, but bear with me. Your basic task worker represents the majority of remote workers now, as it has in the past. However, with growing graphics content, many workflows that used to fit task worker criteria now require higher performance infrastructure. We'll call this group the knowledge workers. Moving up again in graphics intensiveness, you get into your power users doing collaborative design work and visualization tasks. At the high end of the infrastructure performance requirements, you find your high-end design and engineering users now working remotely instead of at expensive workstations. Let's begin by walking through each of the personas and starting with the task and traditional knowledge workers. We'll characterize these persona types by outlining some typical workloads and looking at trade-offs or priorities. First, we have our task workers and traditional knowledge workers. These users are typically single small monitor users doing data entry, call center operations, and possibly light video conferencing. The user interfaces are usually simple 2D graphics and text. Azure Virtual Desktop sessions, hosted on general-purpose virtual machines, are an ideal solution for this category of user. For those virtual machines, the DA series is your best bet. DA series VMs offer higher VM performance compared to other general-purpose families, and they offer a great price point. So what we see is you can get an excellent dollar per desktop ratio by using the general-purpose virtual machines for this category. Next, we'll move to modern knowledge and power users. This class of user is doing more heavyweight graphics. They're doing more rich content, more PowerPoint, more collaboration, and possibly even some basic design applications. Before we dive straight into a recommendation, let's look at what it means to be a modern knowledge or power user. The reality is many applications and workflows today are graphical in nature. Video conferencing, Power BI, collaboration tools, design tools, all benefit from or may outright require a GPU. And the solution of adding CPUs to solve the user experience problem won't work for an application that needs some GPU resources. However, many of these applications or workflows don't need a full GPU, or they don't need a GPU all the time. So there's an interesting dilemma for IT here. You run out of steam with CPU-only VMs, and the cost per hour has traditionally been much higher for GPU-accelerated VMs. Multi-user GPU solutions based on other technologies add licensing costs on top of already high GPU VM costs. The gap between the affordable CPU-only VMs and high-priced GPU-based VMs is what we affectionately call the missing middle. This is the business challenge that NVV4 is designed to solve. Now let's get into defining our modern knowledge workers and power users. Typically, they have a dual monitor configuration. They're doing multimedia collaboration. They have many applications and windows open, just like myself. They're working on graphics-intensive applications, and they need a smooth desktop experience for maximum productivity and engagement. The fractional GPU capabilities enabled in the NVV4 virtual machines brings down the entry cost for GPU acceleration for multi-session Azure Virtual Desktops. So the NV16 ASV4 is an ideal starting point for this class of user. Next, we'll cover our low-end workstation users, but this group also includes some power users. Here, our users are designers and engineers, and those working with the artifacts developed by engineers. So for example, product lifecycle managers and supply chain managers. The nature of the workflow really defines the difference between a power user and a workstation user. These users are part of the design team. They may be designing high vertex count 2D and 3D models, editing videos, doing digital painting, or doing photo editing. Whatever it is though, it's graphics intensive and a GPU is required, but multi-session is still feasible from a user experience perspective, and of course more economical. The decision here is GPU size versus the number of users. Here's an example of a study that AMD Engineering has put together with AutoCAD. Now note that this is an animation, so the actual experience may come across even better than what you see in this video. I'm going to go ahead and fire this up. Okay, now using a relatively small model, we want to know the session limit for NV16 ASV4. So what's interesting about this use case is the bursty nature of GPU utilization. When you move or redraw the model, you need GPU resources, but how much you need depends on the size of the model for the most part. And while you're evaluating what you see, the GPU is idle. Someone sharing the host with you could use that GPU, which makes this workload really great for multi-session environments. I'm going to pause to let you take a look at the demo. And the full demo is about 3 minutes long, so we'll go ahead and move on. But if you want to see more, you can check out amd.com/NVV4. Last, we'll move on to high-end workstation users. High-end workstation users typically run applications that make continuous and heavy use of GPU resources, and they'll typically benefit from single-user deployments. The virtual workstations can be sized based on the required GPU resources versus the cost to best fit the user's needs. These users can typically be consuming 3D data continuously. They probably have 2 4K monitors, and the software that they use is very important for their solution. And here's another demo I want to show you for workstation class graphics. Again, this is an animation, so the real-life experience may be even better than what you're seeing here, but I think this is a pretty good representation. So I'm going to go ahead and get this fired up. The first application shown here is Autodesk Maya on NV16 ASV4. We're playing back a MASH procedural graphics animation, and then we open Arnold Renderer to concurrently see playback both in the Maya viewport and a preview of the proposed HD final render animation in Arnold Renderer Viewport. The second application is Autodesk Inventor Professional 2021. Here we're manipulating a multi-part model of a fishing reel. The model consists of over 90 separate elements. And the third application is Adobe Premiere Pro 2020. We're showing the Lumetri plugin color grade of a 4K video clip in an HD sequence with render and playback of the complete sequence. And what's really interesting is that yes, you can do all of this on a Surface tablet instead of an expensive workstation. Now, in summary, AMD offers a wide portfolio of AMD-based virtual machines in Azure to meet the demands of modern apps and operating systems. Our general-purpose DA series VM are an excellent fit for task and traditional knowledge worker workflows, and GPU-accelerated VMs are a great fit for modern knowledge worker workloads as well as workstation and power user types of workflows. We have a wide array of resources on AMD.com and Azure.com that you can check out at your leisure. We thank you so much for your time, and we invite you to check out AMD-based VMs in Azure.